Hello, how we doing today? Let's at least turn this. Ooh, sorry about that. Sorry about that. How we doing, DJ? I know, but why'd you call yourself the dummy? I don't understand. I can't be bothered to get my Chromebook feeling dead? Oh, fair enough. Fair enough. I haven't seen you in a while, Khadija. What's going on? It's good to see you, though. It's your other Twitch account. Okay, that's fair. Good to see you today. It's like I haven't seen you in like a week. So hopefully you're doing really, really well, Khadija. Sitting, chilling, having a nice time, hopefully. Getting some math homework done things. Been lurking quietly. I've just not said anything recently. Oh, okay, that's fine. I always encourage everybody to participate, just in case if they have questions and they can start understanding things if they're having a tough time. So, you know, I don't want you to feel left out, It's kind of important. I lurk quite often myself, so yeah, to Matt's last lesson today. Very good, Gomesh. Excellent. Hopefully you've been learning a lot. Josie, hello. Good morning slash afternoon to you. Yeah, Khadija said morning slash afternoon. Good, Brian. Good afternoon slash morning. How you doing? How we all doing today? Hey, we got some good people here in the chat. Excellent. I like it. All right, we're here for a fresh week, a fresh Monday morning slash afternoon, most definitely. Hopefully everybody is doing absolutely fantastic. Hopefully everybody can. Hopefully everybody's got good vibes going today. Maybe some of you have done the test. I don't know. Test has been posted, so you've tried the test already. Again, just really struggling with waking up. I was finally asleep by 10, but the dang tornado alarm went off twice. Oh. I guess I slept through that. I saw some knocked down trees over by knocked down branches and stuff on not trees but branches and stuff near my place. Actually, next to my car there was one big branch, so I was like, "Ooh, that was close." Having breakfast or dinner sounds like a plan to me. Some scrambled eggs, some toast, orange juice for dinner. Can't be all bad. At McDonald's you could do breakfast for dinner. Oh, breakfast all day, every day. Yeah, was it how bad? How bad was the tornado like weather? I slept through that whole thing probably like a brick. So, I didn't hear a thing. It's really bad. You sleep through some tornado alarms. That can't be good. Well, whoops. Hey, Jess. Jess, good morning slash afternoon. How we doing today? How we doing? Hopefully we're doing well. I hope that the things around your houses weren't too damaged or things like that. Um, it's just a really bad thunderstorm, no tornado on my end. Yeah, I woke up and I saw the tornado alert on my phone, like till 11:30 today, and I'm like, I kind of just like, okay, whatever. Then I woke up. It was like 5 o'clock in the morning. That's because I slept like a log, though. So I went to sleep at around 5 p.m. and then I woke up at 5 a.m. because that's what my body wanted to do. And I don't even understand why, but it just wanted to. I guess it's one of those things. One of those weird days you're gonna get like a whole boatload of sleep. It's just wanting to. Can't really argue with the body at times. I'm glad to see everybody's safe, at least. At least as long as everybody's safe, then that's good. You know, probably proceeds to play fun. Yeah, that's true. Can't argue with that. Proceeds to play Final Fantasy for a while. Trying to get through main quest storyline here. Want to get my 70 gear. Item level 400 gear. You know, I gotta just play through main story quest for a while. Then I gotta play even more main story quest even after that. Like, I have like 100 main story quests to go. It's crazy. Just to catch up with like the current content. On the positive side, I'm level 72. I'm 8 levels from level cap. Can't really argue with that. I was working on the notes this morning too. So not like I just play the game, you know. I work on notes. I work on you guys, you know. Takes first priority in the morning. Getting these notes out of the way, boom, boom, boom. And then I got like my lecture in mind, and then boom, we do it, and then there you go. I got 2 hours worth of content within 3 minutes in my brain. All right. See, it all works out in the end. All right. Anybody else do something interesting for the weekend? Hopefully you guys did. I was out a lot this weekend, so this weekend was like super busy. Next weekend won't be as busy, but next this weekend was really busy. I was out downtown a lot, so I'm often reminded if I go downtown that how terrible it is to drive downtown. Oh, so brutal. Traffic there is just a nightmare. Hate it. Hey, good morning / afternoon. Hey, I had a great weekend. Just super busy, but I had a great weekend. You worked all weekend, Brian? You know what? I call that productive and monetarily. You gained monetarily. That can't be such a bad thing, even though it may not be the work you want to do in the future. I totally understand that. We've all had to go through our trials and tribulations, Brian. I'm totally with you 100%. Family from Arizona came on for a few hours yesterday, but that's all. Only for a few hours? They just stopped by and then they kind of left? Are they like in the middle of something? Seems kind of weird to only stop by for a few hours. Kind of weird. Oh, okay. Alright. Okay. Watch football / yes, there you go. It's still the Euros, that's true. Got a couple games going on now, so 100%. Yeah, they're doing their own thing with their friends. Alright. Hey, why not? Good to see family every once in a while. Can't be bad. Let me stop this for a second. Alright. Let me go ahead, let's go do some intros here. And we'll go ahead and get started here with some new material. But got one thing or two to talk about. But anyway. Those clap again. Better. All right. Okay, let's get started today. Welcome back to Monday. Hope it a nice weekend. All right. Hopefully everybody also had a wonderful Father's Day yesterday. If you celebrated Father's Day, hopefully you had a nice time with your dad. Hopefully you had a nice time with the family, or whatever you were doing here. Hopefully you had a wonderful time. I hope everybody had a chance to at least relax. Or Brian says he worked. Hopefully, again, you get a little bit of out of it. You know, get a little bit of money, get a little bit of have a grand old time. You know, bigger and better things, everybody. Bigger and better things is what is on the horizon. But hopefully, at least you had a chance to relax a little bit, sit down and have a little cup of tea. Can't really argue with any of that. All right. In any case, I want to welcome everybody back here to some Math 112, some college algebra. All right, so hopefully everybody doing absolutely outstanding. So let's pick up where we left off last time. Last time we talked about long division with polynomials. That is what we did here last time. And so we're going to pick up where we talked about division of polynomials here, and we're going to expand upon that topic here just a bit here today. All right. But we're going to be doing a couple concepts that have stuff to do with each other here. So we're going to pick up from question number, let's see. So it's question 2 on the last handout here from the 3-3-3-4 handout. Okay, so from the 3-3-3-4 handout, we're going to go ahead and start from question number 2 as we're going to be talking about synthetic division. All right, so let's take a look at question 2 here. Let's look at that right now. The screen here. Go. All right. I'm gonna need to kind of move this over to the side here, or my face out of the way. Actually, let me move my face out of the way. To the no face scan. Just a moment. All right. So I'm gonna put this up on the screen here first and foremost. Here, number 2. What are the rules you need to follow to do synthetic division? Okay. So we're going to be taking a shortcut method here into doing that same type of division that we talked about last Thursday when we did long division. However, as you can see here on the screen, there are several rules that we need to follow here because it can be restrictive in terms of how we can apply synthetic division. We're going to do a couple of these examples here together most definitely, and we'll see exactly how we can get down to the same results as if we did long division here. Obviously, synthetic division much shorter, but let's go over the rules here carefully one by one, and hopefully give you some time here to also write it down on your notes. As you can see, there's quite a few rules as you can see here. So, rule number 1 here is that you can only use synthetic division when dividing by a degree 1 polynomial, such as x minus a or x plus a. So if you had, say, even the same thing, if you had 2x plus 1, you could also divide by that. You could use synthetic division for that as well, and we'll talk about those kind of things here. But in any case, when you have a degree 1 polynomial such as x minus a or x plus a, that's the only time where you could use synthetic division. So again, also as a reminder here, again, if you're dividing by, say, x squared plus, plus x plus 1 or whatever, you cannot use synthetic division in those cases. So only degree 1 polynomial. All right. Question Rule number 2, question 2. Rule number 2 here. You will have two sides separated by a bar, the outside and the inside. So we're going to talk about this here. Some of the things that I've written down here will seem rather confusing just as words, but when we actually do it in actual practical, example, it'll make a whole lot more sense. Okay, so, but just kind of what I tried to do here is just break it down one piece at a time here about these rules, so at least you know what the expectations are. All right. So, number 3. On the outside, you will put the number opposite of what you are dividing by. So, and put the in parentheses. So you'll have plus a if you're dividing by x minus a, and minus a if you are dividing by x plus a. So if we're dividing by, say, x plus 1, we're going to put a minus 1 on the outside. If we're dividing by x minus 3, then we're going to have a positive 3 on the outside. Okay? I'm going to be having that. All right, number 4, on the inside, we're going to put all the coefficients of every power from the highest to the lowest. Okay, and so again, I put here as a warning, all powers must be represented. So if 1 is not listed, again, mark that coefficient as 0. This is similar to what we talked about here last time. We did long division, is that we still needed to make a column for that power, even though we kind of skipped it in the polynomial. That still has to apply here as well. All right, let me back here now. Not past the first 2 here. Ice. There we go. All right. All right, number 5. Let's go number 5 here. Bring the first coefficient straight down in the results row. And we'll talk about that here in a second. I'm going to kind of go through these last guys here a little bit quicker. Number 6, multiply the first coefficient and multiply by the number on the outside. Put this result under the second coefficient. Number 7, add straight down and put the result in the results row. Number 8, rinse and repeat steps 6 and 7 using the previous result until you get all the columns filled in. All right, and note, the result here is always 1 degree less than the original polynomial you divided. Okay, now you're probably saying, whoa, 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 you went by that very fast. I said, yeah, that's pretty fair. But let's look at an example here. I'll give you some time to go ahead and copy this down as well. So no worries about that. But what I am more concerned about, of course, is to take a look at actual numbers and put it into practice. So let's do that. Okay, why do you do... Anyway, it's over. All right, there we go. All right. Okay, so let's go ahead and just put it on, again, we'll put it on the big screen here. Here. All right. So let's make an example here. All right. Let's just do a simple example. All right. And so let's do 3x to the fourth minus 2x to the third plus 10x 5x plus 2. Then we're just going to divide that by x minus 2. Okay, so this is our first example here. We're going to take this this polynomial here. We'll have 3x to the fourth minus 2x to the third plus 10x squared minus 5x plus 2. Okay, and we're going to divide that all by x minus 2. So let's talk about, again, this is going to be allowable because we're dividing by x minus a or x plus a. So we can definitely do synthetic division on this. Now, the way this is going to work is, let's go over each of these rules here carefully with the numbers that we now have in front of us. Okay, so first of all, I'm going to have a little bar here. All right, so I'm just going to make a bar here. That's fine. To the left will be the outside. To the right will be on the inside, just like a division problem. Now, the number here on the outside, I'm going to do rule number 3 here. It says, put the number opposite of what you were dividing by. So if you see here, we have x minus 2. So on the number here on the outside specifically is we're going to go ahead and put a positive 2 out here. Okay, so because again, 2 would be the factor here. So again, that is what we're going to put here on the outside. On the inside, which is the rule number 4 here, we're going to put all the coefficients of every power from highest to lowest. Okay, so every single coefficient we see here, so every number in front of every letter, that is essentially what we're going to be doing here on the inside. So we're going to start off with 3. We'll have minus 2. We'll have 10. We'll have minus 5. And we'll also have positive 2. Okay? So I'm just going to go over this again, just real slow, like at least I'll show you this process here from start to finish. All right. We'll put a little bar right here. This will be underneath here will be our results row right here. We'll take a look at, but you'll see exactly how we met this out. Okay, so we've taken care of the outside and we put the proper numbers here on the inside. Now, the way we're going to go ahead and approach this here is, again, we're going to bring number 5 here. We're going to bring the first coefficient straight down to the results row. So basically, draw a little arrow here. This, whatever this first number is, doesn't matter. In this case, it happens to be 3 because that's what we made up. I'm going to just bring that 3 straight down, just like so. Easy peasy lemon squeezy. All right. Now, this is where the kind of again, first part of this rinse and repeat process is going to kind of take place. So let's go to number 6. We're going to take this first coefficient here, this 3. We're going to multiply it by this 2, this number on the outside. So we know that 3 times 2 is 6. So we're going to put a 6 right here in that right below minus 2, because it says here, multiply the first coefficient, multiply the number on the outside, and put this result underneath the second coefficient. So just like so. Okay. All right. Now, take a look at number 7 here. This is why number 7 is its own kind of deal. Number 7 says add straight down. So you should add straight down. That's the most important thing here. Adding straight down, probably the most important thing here to recognize. We're not doing regular division where we're subtracting. Now we're adding. So we do minus 2 plus 6, which is positive 4. And now we just repeat this process going all the way down the line. So we do 4 times 2, which is 8. And here we're going to have 10 plus 8, which is 18. We'll do 18 times 2, which is 36. Negative 5 plus 36, which is 31. 31 times 2, which is 62. And then finally, 2 plus 62, which is 64. All right. Now, what's going to be also helpful here as part of the synthetic division process is to separate out that last number. I'm going to draw a little box around this last number here on purpose. Okay, so you'll see why here in just a second. But before we move forward here, are there any questions about how I got this last row? Okay. Again, if you feel I'm going too fast, please stop me and just ask. All right. Now, here's the important part here. Let's talk about what happens afterwards. Now, these look like random numbers. However, each of these numbers will constitute the answer to our problem here after doing our synthetic division. Let's take a good look here at the very bottom. The very bottom, I put this note here on the very bottom for one other extra reason. The result here is always 1 degree less than the original polynomial you divided. And that's because we only divide by a degree 1 polynomial. So basically what that means is that if I started with a degree 4 polynomial, because that's my highest power is x to the 4th, then I know my answer is going to be x to the 3rd and so on and so forth all the way down. So what that means is that basically here, starting with this 3, this is the number of x to the 3rd terms you have. This is the number of x squared terms you have. This is the number of x terms you have. 31 here is the number, and that here, this 64, will be your remainder here at the end of the day. So I put this on the bottom here to remind myself of what each of these particular numbers here represent. So now if I want to write in my final answer from this problem here, this random problem, my final answer here will be 3x to the 3rd plus 4x squared plus 18x plus 31. And then this will be plus, and then we write the remainder here. Remember, we write the remainder the unusual way here. Remainder over the divisor here of 64 over x minus 2. And that's going to be our final answer for this problem using synthetic division. Okay. Are there any questions about that before we move to our next example? Okay. So hopefully I made that a little bit clear there about how synthetic division will go. Normally this takes a little while to do, but I think with the pre-written notes for this one actually takes a little bit less time, which is good. So I really prefer just showing you examples and stuff, so you know how it goes. Steven, my dude, how you doing? Fritz, my friend, how you been? Good to see you. Okay, let's go ahead and try another one here. All right, let's go ahead and see another one here. Okay, now that we have a good grasp on how this will go, and I'll this time you guys can guide me here. I'm gonna make this a bit bigger here. Look at a bigger. All right. Okay, so let's try this one here. Try the next. All right. So, okay. Let's do 2x to the fourth minus 5x squared minus 20x plus 11. That divide by x plus 3. Okay, so we'll go with that. All right, there we go. Okay, so this is what we have here. Perfect. Okay. Had a great weekend, Fritz. Absolutely, 100%. Had a wonderful weekend. I hope just watch them. Yeah, I was out in the town pretty much hanging out with a friend all weekend. Went to the Cubs game on Saturday, even though they lost pretty bad. We had a lot of fun. So, all right. So I agree with you, Brian. That's true. I do need 0 cubed here, but let's set up the problem here, okay? And then you tell me where that 0 needs to go. All right. So let's set this up here appropriately. Let's put a little bar here. All right, so let's just go at one at a time. What number do I need on the outside here? Let's answer that question here first. What number should go on the outside here in this case? All right, I totally agree with that, right? If I have plus 3 here, right, according to our rules, we need the opposite number here. So go back to our rules here for just a moment, all right? And we got to follow the rules here carefully. Be sure you have these in your notes. Again, you will always put the number opposite of what you are dividing by. So you have plus a for dividing x minus a, and minus a for dividing by x plus a. So just be a little careful though, Bernice. It's not exactly what you see. It's always the opposite of what you see for the number on the outside. Okay, how about the numbers on the inside? What numbers do we have here on the inside? Numbers do we have here on the inside for this problem? 2, 0, minus 5, minus 20, and 11. Okay, that is correct. Very nice. So we have 2 for the x to the fourths, but every power has to be represented. So even though I skipped x to the third, I still need an x to the third guy, just like I did the long division last week. Same dealio. So I need that coefficient of 0. Ooh, why did I put 20x? I don't know. There we go. Sorry. Force a habit. All right. Okay. All right, perfect. All right. So everybody's on the ball here for this. Got to put that 0 down. So again, got to look at it carefully. Make sure we put every power being represented. All right. So tell me, what do I do next? What should I do next here? 2 times minus 3. Right. Don't forget here. Right, Lysiderna, that's correct. So don't forget here, just draw that little arrow so you remind yourself to bring down that 2. Right? So, Brian, you're correct. Just be sure you draw that arrow there so that way you give yourself again, you're like, oh, okay, got to bring down that 2. And then you do exactly as you said there, Brian, multiply by minus 3. I absolutely agree, 100%. All right, so we bring down the 2. We're going to do 2 multiplied by the minus 3 here. And so here we get minus 6. Okay. Now once again here, let's answer this question here. Do we subtract or do we add? Do we subtract or do we add? Okay, very good. All right. Nice, nice, nice. All right, trying to make you, no, I'm trying to make you catch you unawares a little bit, but okay, good. Everybody's on board here. So we're going to go ahead and add here. 0 plus -6 is just obviously the same thing. All right, so we have -6 now times -3. So -6 times -3. Now, again, this is why we just do this carefully here. Just note that there could be sign changes in the middle of this process. So again, -6 times -3 will be +18. So we get -5 plus 18. It will be +13. We have 13 here times -3. That is -39. All right. Add these two together here. Here we get -59. It's awkward. I just randomly picked numbers, so like I said, they could end up to be pretty awkward. Um, and then we have -59 times 3, and I believe that's a positive 177. So, okay. So here we have it. Let's go ahead and put down this last one here. We'll have 188 to be our last guy here. Again, when you're doing synthetic division, make sure you have this little separator out, just like so. Okay. All right. And again, what power should we start with for our final answer? What power should we start with for our final answer? Okay. Good, 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 good. Nice, nice. I agree. All right. I know what you meant. Yeah, Brian, you're still good. You're still good. So we start off with x to the third, and then we just work our way down, right? You did say it. I don't know why you're doubting yourself there, buddy. You're fine in my book. All right. So here we have our final answer here of 2x to the third. 12-hour shifts. Can't argue with you then. You ain't wrong. 12-hour shifts going to do that to you. We have 2x to the third minus 6x squared plus 13x minus 59 plus 188 over x plus 3. All right. That's our final answer for this problem. All right. Any questions about that so far? And you're probably wondering, you're probably saying, well, where's this going to be really important for today? Why is this going to be certainly a thing? All right, certainly this is a much shorter method than doing long division, but of course we're restricted to only dividing out by degree 1 polynomials. Okay, but why is this going to be kind of the important crux in the matter here for what we're going to be doing here today? Well, there's actually a couple of very important results that you can conclude here from doing synthetic division. Yes, of course, Blink. That is not a problem. I'm going to go right back to them. So let's go ahead and take a look here at so these are the rules here. I know there are a lot, so if you want to take like a screenshot or something, that'll be okay. Yeah, we're at oh yeah, I know you're oh yeah, you got a few seconds delay there. Yeah, go ahead and take a screenshot because I gotta move forward because I know there's a lot on the page. So once you guys got some screenshots, just let me know and I'll just move forward. All right. I'm gonna move a bit forward once you guys go. Okay. All right. So let's talk about the resulting things that we get here from synthetic division. Okay. Now, oh, I meant to do it the other way. Sorry. We're gonna get to this part here. Okay. So the next thing that we need to talk about here is the two results that are kind of the fallout from synthetic division here, and that is number 3. What is the remainder theorem? All right. So we talked about the remainder here. It says if the polynomial f of x is divided by x minus a, and that could be x plus a, it doesn't matter, then the remainder is f of a. Now you're probably saying, well, hold up a second. What does that mean in terms of what what we just did? Well, let's go back for just a moment, and I'll get to the next question here really quick. Well, if you take a look here, we did this, and we got a remainder here specifically of 188. The contention here is underneath this particular remainder theorem is that we can take f of minus 3. And if we take f of minus 3, that is going to equal 188. Okay, that is what it's basically saying. All right, so if we take f of minus 3, that should also check out to be minus 188. So let's check it out. Let's see if that happens to be true. So again, f of minus 3 will equal 2 times negative 3 to the fourth. Okay, minus 5 times negative 3 squared, minus 20 times negative 3 plus 11. So let's say we plug this into the calculator, and let's say we went ahead and say, all right, is this indeed going to be 188? All right, well, let's find out. I'm going to kind of shove it across here, so apologies for the screen transitions here a little bit. All right, scroll down here to get my bearings here. All right, so let's say I entered it in exactly as it says. So again, put negative 3 here to the fourth power. Okay, but minus 5, but negative 3 squared, minus 20 times negative 3, and then plus 11. So we'll see what we get here. So, and as you can see here, we indeed get exactly 188. All right, so it does check out definitely that we indeed get exactly 188, the remainder that we got here using synthetic division. All right, so that's essentially what it's basically saying at the end of the day. So a nice way you can actually get any function value by using synthetic division, albeit again only with degree 1 polynomials. But still pretty easy to get like a number, and you can just use synthetic division to find it directly. So very convenient. All right, any questions about that before we move on? So just a quick thing to make note of in that question. Hopefully that's not too bad. All right, no questions. All right, let's look at the next one here. Okay, so I'm going to look at the next question here, and gonna transition quickly from number 3 here. Not so much transition, but use a very important result of number 3. If it's true that x minus a says, okay, we plug it in and we get the remainder is f of a. Specifically, we want to look at the factor theorem, which is a result of the remainder theorem. It says if x minus a is a factor of a polynomial then of f of x, then f of a has to equal 0. So if we get a 0, let's say we do synthetic division here, right? And we get a 0 remainder at the end of the day, all right? Then that particular polynomial, like x minus 3 or x plus 2 or whatever, is going to be a factor of that particular polynomial, all right? This will lead into very important results, as you're going to see here for pretty much the remainder here of the time for the most part. Well, maybe even the remainder of the time. We'll see how. I planned up to getting. We'll see. We'll see how things go. All right, we'll go with that. We'll go with that. All right. Thank you for the hydrate, Jess. Okay. So let's take a good look here. With let's take a good look here at number 5, and we're going to see exactly how we can view certain problems in the next section here, which is going to be a lot of examples here are going to revolve around the subsequent questions here, 5, 6, and 7. All right. Let's look at question 5. Question 5 asks, what is the rational zeros test? So what we're going to be doing here in the section 3.4 is talking about how to find zeros of polynomials. That's going to be our big thing here that we're going to be doing in that section. Now, in order for us to understand that, well, that's why I introduced synthetic division here today, is because of the fact that that's going to be kind of our linchpin here in order to find our particular zeros. So, however, we do need what's called the rational zeros test in order to see what our possible zeros are going to be. So it says, let's take a look here at the question here. It says, if f of x here is qx to the n plus dot 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 plus p. Now, I know it seems really weird about why I chose those letters, but those are the first letter, which is q, and the last letter, which is p. The last thing is p. Is a polynomial, then the possible zeros of the polynomial are the factors of p divided by the factors of q. And we could say, okay, well, plus or minus is in play. All right, so I want to put that there on purpose, but let's talk about exactly what I mean by that here. So let's look at an example here about what that actually represents. So let's go to our paint tool here. Again, if you have your calculator out here, we will be using the calculator here today pretty extensively for these questions. So um, as we do want to expedite the process a little bit. So if you do have that, please go ahead and take that out. Yeah. All right. In any case, let's look at an example here. So let's say I have, I'm just going to go with something easy here to start with. So let's say I have 2x to the third minus 3x squared minus x plus 1. Okay, so let's actually no, let's go with something different. Sorry. Let me go with plus 8. I want to showcase one thing. So, okay. So let's say we have this. Okay, fine. Seems fair. All right. So what we're going to do here specifically is we're going to just take a look here at two numbers specifically. All right, we're going to look at p, which is the last number we see here. Label that last number. We'll label that p. And the leading coefficient here, this 2, we're going to label that q. Okay, so our possible zeros here, note I did write possible underlined and in caps for a reason. So our possible zeros here are going to be factors of 8 over the factors of 2. Okay, let's talk about this here for just a moment. What would be the factors of 8 and what would be the factors of 2? Let's just break it down one piece at a time here. What are the factors of 8? You tell me here, what are the factors of 8? What are factors of 8 here? One, 8, 2, and 4. 1, 2, 4, and 8. 1 and 8. Okay, 1 and 8, 4 and 2. Okay. All right, very good. All right, so it's a combination, right? So 1, 2, 4, and 8 are going to be our factors of 8. Now, we're going to put those down, definitely for sure. Okay, but let's not forget here that plus or minus is in play here. Okay, so it's not just going to be our positive numbers here that we're going to look at. We're also going to look at their negative counterparts. So I'm going to do plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. We are definitely including the negative values as well. Okay, so that'll be important here for what we're going to be doing a little bit later. So you need to keep these in mind. Okay, let's look at the factors of 2. What are the factors of 2? Okay. Okay, good. Plus or minus 1 and 2. Okay, so we know that since plus or minus is in play, we have plus or minus 1 and plus or minus 2. Good. All right. So those two have to be entered in just like so. All right. Now, what we're going to be doing here is we're going to be dividing each number on the top with each number on the bottom. Okay. So basically, we are going to produce a list of possible zeros that would divide this particular polynomial. So I'm going to take, say, for example here, I'm going to take plus or minus 1 and divide it by plus or minus 1. So essentially 1 divided by 1. Now, of course, 1 divided by 1 is just 1. That's not going to change anything. Same thing with plus or minus 2 over 1. That's going to be 2. Next, I got plus or minus 4 over 1. That's 4. Plus or minus 8 over 1. Well, that's still 8. So again, obviously, 1 doesn't do anything in terms of like changing it. But again, you just have to divide each number by that 1. And those are our possibilities, at least the first 4 possibilities. Okay. Actually, first 8, technically. Now, we're going to take each one of these numbers here, 1, 2, 4, and 8, and now we're going to divide it by 2. Okay? So we may get repeats, and if we get repeats, we don't count them, okay, because we already have them written down. So let's take a look at the first one here. We have plus or minus 1 over plus or minus 2. Well, that's not a repeat because that's plus or minus 1/2. Remember, that does count, okay? Look at fractions, that counts. Here we get plus or minus 2 over plus or minus 2. Well, 2 divided by 2 is 1. So we already have 1, so we don't need to repeat that. We have plus or minus 4 over 2, which is 2. We already have 2, so we don't need to repeat that. And we got 8 over 2, which is 4. And we already got 4 on our list, so we don't need to repeat that. So here, what we have to start with is we have an infinite amount of possibilities. And now we've narrowed down the possible rational zeros here down to 10 possibilities. Okay, so that's what we've effectively done here in this particular example so far. All right, so again, these are the possibilities, but these don't necessarily reflect all the zeros in the polynomial. Okay, and we'll see why when we go ahead and put 2 and 2 together here. Okay, but before we do that, are there any questions about this so far? All right. Now that we have these possibilities, okay, we're going to push this a little bit further, okay? We're going to see exactly how we can find these zeros of a polynomial. All right. Now, in order for us to do that here, we're going to need maybe one more rule here, and then we're going to go ahead and put the whole thing together here. We may continue on with this example here, so that way we can see maybe what will happen. I'm not so sure. We may or may not. Probably should check that here really quick. I made up these numbers here just as a thing, so I don't know if the numbers will work out nice. I want to show you like a nice example first, and then and we'll do like tougher examples. So I don't want to be like, oh, you automatically get nothing. That would be bad. I'd rather not have that happen. Oh. Yeah, that's not. I was afraid of that. All right. In any case. Okay. All right. We'll do another example. You'll see how that works. All right. All right. So what we can also get here as zeros of polynomials is we can get conjugate. We can get not conjugate. We can get complex zeros. Pardon me. Again, complex zeros are like 3 plus 2i. So remember that I was the imaginary number we talked about here at the very beginning of class and all that stuff. So some problems here will actually give you a complex zero here. Again, what we need to understand is that complex zeros here always come in pairs, and that's what number 6 here talks about. It says, what is the conjugate pairs rule for complex zeros? So this basically says if a plus bi is a zero of a polynomial, then so is its conjugate a minus bi. So if I told you, hey, 3 minus 2i is a zero of the polynomial, well, then you can automatically assume 3 plus 2i is also a zero of the polynomial. Okay, then that makes things very, very convenient. All right, again, that means you always get a twofer. All right, you always get a BOGO. All right, so if you think about it that way, if you get a twofer or a BOGO, that isn't so bad. All right, so that can be very convenient for complex zeros here. Is you have one, you automatically have the other by default. All right, now fine. Talk about a lot of this stuff here, but talk is cheap. Got to do actual examples. All right, and then we can see exactly what we're working with. All right, so how do we find zeros of polynomials? All right, so we're going to break this down here one piece at a time, one step at a time. We're going to do an example. Let's do it out. Let's see what we're working with because we got a lot to talk about here in this first example, breaking it down. All right. So, um, So we have here step number 1. Step number 1 is find the degree of the polynomial. This will equal the max number of zeros. So let's say you're not sure how many zeros do I need to find? How many do I need to find before I have to stop? One of the always classic things in math. When do I know when to stop? Well, fortunately in this process, this is exactly going to tell us when it's going to stop. And basically it's going to tell us when to stop is how many zeros that we found here as part of the polynomial. Now, in order for us to go ahead and met that out, let's look at an example here right away. And grab an example here first and foremost. I want to grab a nice example here first, and then we'll look at something a bit harder. I don't want to be like give you like a crazy example and magically get bad things. Try and get. Yeah, that works. All right, so let's try this one here. All right, so this one's number 47 on page 406. All right, good bean. All right. Okay, so here I get 3x to the fourth minus 11x to the third and minus x squared plus 19x and then plus 6. All right. Okay. So this is our polynomial here, okay, that we're going to go ahead and break down one piece at a time. And we're just going to see what we get. Okay. So let's go at one step at a time. Let's see what we can do. Let's get it. All right. So again, let's talk about our max zeros here. What is the degree of this polynomial? What is the max number of zeros that we're going to find here for this example? What are the max number of zeros that we're going to find for this example here? Again, taking a look at the degree of this polynomial, what's the maximum number of zeros that we're going to find here in step 1? All right, Nicholas says 4. Right? If you find what the degree of the polynomial is 4, right? So the degree of the polynomial is 4, then the maximum number of zeros for this polynomial is also going to be exactly as Nicholas has stated here, is 4. Okay? So if you don't recognize that, then there's going to be problems. Okay? I could guarantee you that. So, because then you're going to keep going, and then you're always going to question yourself, be like, hey, do I got to stop or not? Now, understand that you may not find four zeros right away. Okay? You may not find 4 zeros. Okay? Right away. So that may or may not happen in these examples. Okay? So again, you have to be a little bit wary about that. You may end up with 3 zeros. Maybe 1 zero repeats 2 times. That's certainly possible. Okay? So again, but we know that the maximum number here has to be 4. Okay? By default. Okay, let's do step number 2 then. Step number 2 says we have to do the rational zeros test and find all the possible zeros. All right, let's do the rational zeros test on this particular polynomial. All right. So the number of possible factors is always the same as the number of zeros. Correct. Yes. That is the exact yes, that is exactly correct. So we just have to give ourselves a ballpark. We have to give ourselves at least a small ballpark we need to work in. Well, I don't want to guess, right? I want to say, hey, the degree of my polynomial is 4. So I know at most I have 4 zeros. And that should be good enough. Okay? I don't need to go any more than 4. So fine. That's as much as we can go. Well, again, that's what makes it really nice. Step number 2 here says, do the rational zeros test on all possible zeros. So we have our P and our Q here. What's our P and what's our Q here? If we're going to do the rational zeros test, anybody tell me here, what's the P and what's the Q here that I have to choose for this particular example? What's our P and what's our Q? Three is Q and P is 6. Okay, very good. All right, good, good, good. So again, if it helps, draw a box around those guys. Again, this would be our P here. You guys have done a good job with this though already. So our Q here happens to be 3, so that was good. All right, good stuff. So again, here we're going to have our factors, our possible zeros here. Possible zeros here are going to be factors of 6. That's our P over the factors of 3. We're going to get our nice list of numbers here. All right, really quick here. Let's try and do the next one. What are the factors of 6? What are our factors of 6? 1, 2, 3, and 6. Okay. Okay, I agree. 1, 2, 3 or 6, but what are we missing? I agree. 1, 2, 3 or 6, but what else? Okay, very good. That's exactly right. Plus or minus 1, 2, 3, and 6. Good. Let's not forget about that. Never. Again, if you only put the positive values down, it's not gonna end well. So you have plus or minus all of those numbers, okay? All right, let's look at factors of 3. What are our factors of 3? Plus or minus 1, 2, and 3? Oh, okay. It's scaring me there, Brian, man. Like 2? Where? What? All right. 1 and 3. Holy moly. Brian, I'm going to have to send you back to grade school, bro. Noted never to share 3 pizzas with you cuz 2 will Oh man, I love some of those answers sometimes. It's so funny. I've made mistakes like that too, man. I'm just messing. All right, plus or minus 1 and 3 here. That's correct. All right. Okay, good. I'm gonna get rid of this junk here. All right. Now, what we want to write down next are all our possible zeros after we put this together. Okay. So here, again, we're just going to take each of these numbers here. We're going to divide it by the number here, both of these numbers here on the bottom. So again, we could divide each one of these 1 by 1, 2 by 1, 3 by 1, 6 by 1. You're still going to end up with plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 will be our first 4 possibilities. Okay. Now, not quite done just yet, though. All right, so we have those, but we also have a few more possibilities here. Let's take a look here. First of all, we have 1 over 3. Okay, that's correct. So plus or minus 1/3 here. We have plus or minus 2/3 as well. So 2 over 3 plus or minus 2/3. We could do 3 over 3. 3 over 3 is 1, so we already have that. That's already been repeated, so we're not going to write that again. And we have 6 over 3 here, which is 2. So again, we already have that in our list, so that's fine. So these are going to be our 1, 2, 3, 4, 5, 6, 12 possibilities here that for our rational zeros. And again, so let's understand one thing here. 4 of these may be our winners. I don't know. Okay, I may end up with 4 of them being our winners. Maybe I'll end up with 2 of them being our winners, and maybe the other 2 are going to be complex zeros or square roots or something. That's entirely plausible. Okay, so in some cases you could end up with all 4 of them being winners. In some cases you could just end up with 2 of them being winners. That can happen. Okay, some cases you can end up with none of them being winners, but we're not entertaining those examples, so no worries. Okay, so okay. So the real question becomes is that what are we going to do next to find our zeros of our particular polynomial? Let's go to step 3. Step 3 says to use the calculator to find all the rational zeros. Now you're probably saying, well, how do I go ahead and do that? All right, I'm going to need to zoom out here for this because I need to get a little bit of space here to write zeros for step 3. Let's do that next. Now I'm going to showcase exactly step by step about how to find these zeros of the polynomial. And again, we have 12 possibilities, but some examples could have a lot more possibilities than just 12 possibilities. Now you can actually physically check for each one. You could plug it into the polynomial and see if you get 0. But that's quite a long process to do with 12 different numbers, and especially with fractions, that gets to be even more messy than what you had to start with. So let's take our calculator here. Let's go ahead and see how we can find our zeros here a little bit more quickly here and see if we can find at least, hopefully we can find a few zeros here. Maybe we find all 4 zeros. Don't know, but we're going to give it a shot. So the first thing that I would like you to do here first is to go ahead and hit the y equals key on your calculator. All right. Now underneath the y1 function, we're going to go ahead and put in our function here, our OG original function. We're just going to put in just like so. We're going to put in 3x to the 4th, okay, minus 11x squared. X to the 3rd. I'm so sorry. What am I doing squared here? My fault. That should be x to the 3rd. Minus x squared. Plus 19x. And then plus 6. All right. So we have our guy right in here. No problemo. Okay. Once you have that, go ahead and hit second in mode to quit to the main screen again. Okay. So again, I do this just to be on the safe side here that I don't enter in anything else wrong into the Y1 guy there. So again, just making sure things are safe. Because again, as I've said before, the calculator is very picky. Again, we'll just want to be sure we're putting in the right button presses. Okay, so the next part here is that we want to go ahead and take a look at the table associated with the graph. So we're not going to hit the graph key here. What we want to look specifically is at the table of this particular function. So in order to access that, I'll go ahead and put this in chat here. So we're going to hit the second key here. So we'll hit the second key, and then we'll hit the graph key. We'll hit the second key and the graph key to go to our table. Okay? All right. Now, what we can see here on our graph, on our table here, pardon me, is we can see specifically in this particular instance, you get an error. If you hit the second key in the graph key, go back to your y equals. Maybe you hit this and did this wrong here. So again, make sure you have this here properly. All right, so make sure it looks exactly like this, Josie. Probably why you have an error there. If that's the case. And then go ahead and hit second and quit, and then second and graph, okay? Let me know if you have the table that showed up on my screen there. Let me know once you got it there, okay? Everybody else okay? Again, you have different X's and Y's. Again, make sure you entered this in properly here. 3x to the 4th minus 11x to the 3rd minus x squared plus 19x plus 6. Also, make sure that things are turned off. So let's go over this one more time, everybody. All right, you know, the y equals. Make sure any plots that are put up here, make sure those are turned off. Again, this is what you should have here on your screen for underneath y equals. Okay, make sure that this is all in the same row, not all shoved up into one exponent, and you didn't use the negative key in between both of these and things like that. You have to put the minus key between those. So you got to be very careful when you're entering this stuff in, okay? Go one step at a time, okay? If you guys have this down, okay, we'll just go. We'll start from here again, okay? Everybody who has this entered in exactly as you see here on the screen, and I do mean the word exactly. Type done in the chat. Oh, I'm type done in the chat if you have exactly what you have on your calculator is exactly what you see here on the screen. All right, so I want even if you're lurking around using the calculator, I want to make sure that everybody types in done. Okay, I want to be sure everybody's here. Okay, for these examples, I need everybody's participation for this one. Now hang on a second, Brian. Don't work too far ahead. I just want go one step at a time, Brian. You're trying to go like 3 million miles an hour. Do you have this equation put in exactly as it is, Brian? Look carefully, okay? Okay. Graphing calculator required for the class, my dude? Like, there's a lot of things in this class you can't do without the graphing calculator. That's just how it has to be. All right. Posture check. Okay. What's up, my illustrious calculator chargers? Your new one's coming in tomorrow? Okay. Thank you for the posture check, Jess. Josie, how we doing? Are we okay? Calculator's old, that's fine. My calculator, my physical calculator, that is really old. My physical calculator that I randomly found is well over 10 years old. I know this because of the software that's on it. So again, you shouldn't have parentheses here. You could just put the caret key in 4. That's perfectly fine. Okay. So like I can show you here really quick on my old calculator. Give me just a second here. Let me switch this off here. Give me just one moment. So if you're on the super old school calculator, this is what it'll look like. So let me get to my camera here. So on a super old school calculator, this is what it'll look like here if you're using the super old school calculator. This is my old calculator here. So I like the old calculator in one respect is that I know some people have secondhand calculators or hand-me-downs. So I work with both styles of calculator, especially in like statistics. There's a big difference between the two. So I want to be sure that again everybody has that there. So again, at least this for video purposes, everybody can see how to kind of enter that in appropriately. All right. You put it in just like that. Okay, good. Then that's what we're after here. All right, good. I just messed up one part here. So should be a minus next to the 3 there. My bad. Should be minus x squared. All right. So if you got it like that, perfect. Okay. We're going to take a look here. I think maybe I know what the issue is now. All right. So let's go back to the screen here for just a moment. Okay. All right. So if the table's not working out, let's go ahead and take a look here. And let's make sure that your table is set up appropriately. All right. So to make sure that your table is set up appropriately here, we're going to hit the second key, and we'll type this in chat here. Hit the second key and the window key. Let's just go there first and foremost here. Hit the second key and the window key here. So go ahead and do that here. Second key and the window key. All right. And we're going to go straight to this guy here that says table setup. All right, now this is the settings that you should have on your calculator. Okay, so you should see table start should be like 0. Delta table means the increments of your table. All right, should be 1. Independent should be auto, and dependent should be auto as well. All right, so if you have these set up and ready to go, make sure that at least it is set up this way. All right. We're going to change one setting here, but at least I want to start off with a default setting, and then we'll change it over. Type done in the chat once you have that set up and ready to go, everybody. Okay, now let me make one request of all of you here, and that is we're going to make one setting change on this particular menu. We're going to go ahead and change this independent guy from auto. We'll change that over to ask, and we'll hit enter. Okay, so we'll go to from auto, we'll go to ask. All right, that's what we're going to do here in this particular instance. Once you have it over to ask and everything else looks exactly as you see here on my screen, I want you to go ahead and hit second and mode to quit to the main screen here once again. Once you have done that here, go ahead and type done once again in the chat so I know that you're on board. Okay, now the next screen here is going to look a little weird. Okay, the next screen is going to look a little weird, but this is going to be expected. Okay, so don't worry. All right, don't worry about this next screen here. It's going to look a little weird, but that's fine. All right, so we're going to hit the second key, and now we're going to hit the graph key. So we're going to hit the second key and the graph key here, and you should see an empty table just like so. So the second key and the graph key, and you should see an empty table that looks exactly like this. Maybe it has some numbers from before, whatever. Maybe not. Should be mostly empty, but yeah. Type done in the chat if you have that ready to go. If you see like a empty thing, then there you go. Should be in good shape. All right. All right. So now that if you're on board with this, now let's go back to what we see here for just a moment. Now we can go ahead and proceed with the problem here. Now, as you see here on the problem, we had 12 possible zeros, right? That's our possible zeros. Okay, so we're going to check each possible zero in the calculator to see if we can isolate maybe at most 4 zeros to see if it happens to fit with the polynomial. All right. You see how this works here. It's not so bad. So underneath x that you see there on the screen, we're just going to enter in 1. Let's enter in 1 here for x, and it'll pop up a y just like so. So if we type in 1, it'll pop up with the y value of 16. If you entered this in correctly in for y equals, you should have 1 comma 16. Okay. Hopefully everybody got that. Did people, yes or no, did people get that? should have 1, and then you should have a 16 like it says here on the screen. Yes? Everybody else okay? Type yes if you got what you see here on the screen. If you got 1 and 16. Khadijah's like, yay. Yes, okay, good. If we got this on the screen, we tried out 1, we got a y value of 16. What does that represent? Well, unfortunately for us, y is not in this case. 1 is not a 0 of our polynomial, because if we plugged in 1, we should get 0 back, okay? That's what should happen, all right? Unfortunately, it didn't work out. So let's try the counterpart to 1, which is minus 1. If I try minus 1, now let's plug in minus 1 here in for x. Let's see if we get a 0. We'll try minus 1. Oh, you know what? I need to put negative, actually. Sorry. You actually have to use the negative key, so let's put negative 1. Oh, okay. So we found 1 here. Sorry, be careful about that, by the way. It'll tell you an error if you put in the minus key. Put in negative 1 here. So negative 1 is a definite 0. As you can see here, for y, we get 0 back. So we have 1 winner out of 4. So far, so good. Everybody get 0 when they plugged in negative 1? Again, make sure everybody's on the same page here. Yes, with a triple S. That's SS rank. That's triple S rank for you, Nicholas. That's like, super Saiyan God Super Saiyan. SS is Super Saiyan God Super Saiyan. SSGSS. Okay. So minus 1 works. All right, let's try the next one here. Let's try 2. All right, so let's just try other numbers here. 2, is 2 a winner? Yes. Okay, so 2 is a winner. I'm going to put in 2 just like so. All right, so 2 is a winner. Perfect. Exactly what we were looking for here. Let's try its counterpart, because again, we're not quite done because of the fact that we need 4 zeros. We're going to try all of these zeros here to see which works, until we get either 4 of them or we've exhausted all our possibilities. That's how it's going to work. So let's try minus 2, see what we get. Minus 2, nope, not minus 2. Minus 2 is out. So minus 2 doesn't work. Let's try the next one here. Let's try 3. Try 3. Oh, look at that. Well, 3 is a winner. Perfect. All right, so 3 is a winner here. So we've found 3 out of the 4 zeros. So far, so bueno. Let's see if negative 3 happens to be that last 0 there. No, unfortunately, negative 3 is not the last winner. So I'm going to have to move on to 6. Try 6. We try 6. No, definitely not 6. So that one kind of smells. Let's try its counterpart here of minus 6. Definitely not minus 6. That's pretty outrageous. So let's move on to the next one here, which is 1/3. So let's try 1/3. All right, 1/3. Too bad. Looks like 1/3 is a no-go here. All right, so that's no-go. But let's try negative 1/3. Just try its counterpart. Oh, look at that. All right. So negative 1/3 is our last 0. And we don't need to try 2/3, although you could if you liked. If you tried 2/3, you could try it out. Again, those are not going to be zeros for sure, because we've now found 4 out of our 4 possible zeros. So but you get the general idea, all right, about what will happen here in these cases. Okay, so we found our 4 zeros here in step number 3, -1, 2, 3, and -1/3. Okay, let's move on to the next part here, and I'll show you. No, this next step here is going to be a little odd, but it does have its importance. In this particular example, may not be super relevant, but again, at the very least, we'll see what happens here. Um, everybody, everybody okay with this? Any questions about the calculator portion? Okay, no questions? Okay, perfect. I need to get through 2 examples here for this, so I'm a little bit rushing through this because I want the next example to kind of showcase a little bit too. All right. So let's look at number 4. Now, number 4 says, step 4. Step 4 says is to use synthetic division to prove that the zeros you found in step 3 are zeros to factor it out. Now, I know that seems a little strange. You're like, well, we just found the zeros on the calculator. Shouldn't I just be done? Well, the answer is kind of unfortunately no. Because some cases, and we'll see here in the next example, we're going to have to require to see what happens after we divide out our zeros in our particular polynomial. All right, because we may need to actually do more calculations with the actual results. So how does it work here? In this particular case, it's not going to be that big of a deal because we have 4 out of our 4 zeros here. But it is important to get into good practice here, so I am going to do it the way that I would normally do it in a face-to-face version, because you want to consistently do the same process over and over again rather than just skipping. So if I want to show off, say, if 0, let's say I want to show off -1 is a 0 of the polynomial, I start off with -1 here on the outside. I put my coefficients here of 3, -11, -1, 19, and 6. Now again, let's just go through the same synthetic division process, and we're just going to pare it down one at a time. That's it. So again, I bring down the 3 here. So bringing down the 3 here is going to be 3 times -1. That's going to be -3. Here I get -11 plus -3. That's -14. Let's put 14. Here I get -14 times -1, which is +14. So here I get 13 if I add it together. Here I get 13 times -1, which is -13. I get 19 minus 13, or plus -13, actually. That would be 6. 6 times -1 is -6. And as you see here, for the very final result here, we do indeed get 0, right? So if it's 0 for a remainder, we know that -1, again, is definitely a 0 of this polynomial. Okay. Did the stream just go black? Let me check. No, the stream is up. I think it's just for you there. I think just for you. Should not be black. My stream is up and running, I promise you. I have like a couple ways I can check, and I see my stream is actually pretty consistent today. All right, good. All right, cool. Okay, now I want to showcase one thing off here, and you're probably saying, well, how about the other 3 zeros? How do we check those? Well, you could check the other 3 zeros here, but you can actually shorten the process. What do I mean by that? Well, what I mean is that notice we have these 3 numbers here of 3, -4, -14, 13, and 6. If 2 is a 0 of the polynomial like we found here on the calculator, then 2 should be able to divide this resulting polynomial here. Um, 2 should be able to evenly divide this resulting polynomial. So you don't need to keep repeating these particular numbers here, these first initial numbers, over and over and over again. In fact, you should not do that here as part of this process. You should use this result here and then do synthetic division on this and then keep going. So you have 3 down here. 3 times 2 is 6. 14 plus 6 is -8. Get -16. Here we get -3. And -3 times 2 is going to be -6. So here we get 0 once again, which is what we're aiming for. Repeat this process with 3. With these 3 numbers, as you see here, it starts to whittle down to be shorter and shorter for synthetic division, which is fine. We get 3 times 3, which is 9. And we get a 1. 3 times 1 is 3. That's 0. Fine. Okay. And -1/3 would be indeed fine. You could do -1/3 for this last one here. You're going to end up with a 0 remainder here. Remember that we pared this down 1 at a time here, by the way. So don't forget about that. Again, we pare this down here. We have, again, we started with x to the 4th, x to the 3rd, x squared, and x. This would be like your x. This would be your number. So this would be fine to kind of showcase off here. Again, actually, I'll just show this off with -1/3 here, but I'll show off a couple things. So here we just put down the 3. Here we get -1. That'll be 0. So, okay. Now, I'm going to showcase the last part here. I'm going to show off the last part here. And we'll see exactly how the last part is going to work out. Now that we've proven each one of these are indeed zeros of this particular polynomial, let's go to step 5. Step 5 says, write this out in factored form. Okay, so write it in factored form. You write out the factored polynomial. So we have all of these zeros here. All right, so we can write down each one of those factors here. So if -1 is a 0, then basically we have a factor here. So we could say f of x equals x plus 1. Okay, so we could write x plus 1. That would mean -1 is a 0. X minus 2 means +2 is a 0. X minus 3 means 3 is a 0. And x plus 1/3, that also is a 0. We can also take this 3 here that we got here at the very end, and we can put this out front. We could put a 3 here, and this would be sufficient here to showcase our factored form of our polynomial, just like so. And then this would be your final answer for the factored form of the polynomial, along with the zeros of that polynomial. Any questions about that? All right. All righty. Go ahead and put this next one down here. Okay. You do have to do one more here for sure. That's not a problem, dude. I have replays. That's why you can find them here on Twitch or whenever I upload them to YouTube. Okay. Yes, because again, if -1 is a 0, x plus 1 is a factor of the polynomial. It's always the opposite. That's correct, Fritz. All right. All right, I gotta do this next one here. Okay. All right. Okay. So this next one here, I'm going to go by a little bit quicker. So I'm going to just find out how this will work out here. There's just a couple of important points I want to put out here. Okay, first and foremost here, let's talk about, let's have you guys at least answer a couple parts here for sure. How many zeros do we have here? What's my max number of zeros? Okay, no problem. Our max number of zeros here is 4. That is correct. Okay, so we're going to find 4 possible zeros here for this. All right. All right, now step number 2 here is to do that rational zeros test. All right, so again, we're going to have our P, we're going to have our Q. Just as a reminder here, again, the sign doesn't matter about these P and Q stuff. So we have P, and again, Q here will be 1. So here we'll have P and Q here respectively, just like so. Okay, so factors of P over the factors of Q. We're going to have the factors of 8, the factors of 1. All right. So the factors of 8, we found that we've already pretty much stated that from before. Because that is the degree of the polynomial here, Fritz. Degree is equal to the max number of zeros. So put that as a little side note here. So put that as a little side note here. Note, degree is equal to the max number of zeros. That is always going to be true. All right. Now we have the factors of 8 over the factors of 1. So again, so what we're going to get here is this is going to be just simply straight up 1, 2, 4, and 8. All right, no problem. So again, we're going to just figure out here, how many zeros we get here, how many winners we get out of these 8 possible choices. Okay, now do understand once again, it's not a guarantee we're going to find all 4 zeros in this list of 8 numbers. That is not a guarantee whatsoever. All right, so if you thought, oh, I'm just going to magically find all of them, like, no, bro, no, you're not. Maybe not. So it may not happen. So let's see if we can figure out at least maybe let's see if we can see what zeros we get here in this instance. All right, so we're going to go to our calculator here. Oops, need to do that. Do scroll down here. Sorry, force of habit again. A lot of habits. A lot of habits I don't like, but it is what it is. All right. Okay, so I'm going to go ahead and put on the calculator here once again. All right, I'm going to go to my y here. Go to my y equals menu here. I'm going to go ahead and put in the polynomial in question, which you see here on the screen. So we have x to the 4th, all right, minus x to the 3rd, plus 2x squared, all right, and minus 4x minus 8. Okay, so minus 4x minus 8. Okay, so have that ready to go here. We're going to hit second in mode to go to the screen here again. We'll go back to our table here. So we'll hit second and graph to go to our table. Again, you may see all these values here. Just to go ahead, you can actually highlight you can just basically delete all these out if you want to. Hit the delete key. That'll delete all these out, and you can start fresh and new with an empty table. All right. So we'll try out 1. Try out 1 to see if it's a winner. Oops. Highlight the code. And 1 is not a winner, so that's out. Try minus 1. All right, so minus 1 is a winner. That's good. All right, let's try the next number here of 2. See if 2 is a winner. Oh, 2 is a winner. That's good. All right, so we got 2 out of the possible 4 zeros in this polynomial. Thank you for the hydrate, Golmash. Here we have minus 2. All right, minus 2 unfortunately is not it. Remember, we have 4 zeros, maximum of 4 zeros, so we have 2 out of the 4. So we have to try the others and then exhaust our possibilities. So let's try 4. All right, 4 is a no-go. Let's try minus 4. All right, minus 4 is a no-go, so it's down to 8 and minus 8. Well, let's check them out. We try 8. 8's a no-go. Try minus 8. And minus 8 is also a no-go. So far, we have found 2 out of the 4 possible zeros of this polynomial. So we tried it on the calculator. We said, hey, tried all the possible rational zeros here. Tried the numbers. And we got 2 out of the 4. Okay, so this can happen. Again, like I said, it's not a guarantee that you're going to find all 4 zeros here right away. Not a guarantee at all. So this is where that next step that I talked about here of doing synthetic division is going to be incredibly important. This is why we do step number 4 the way that we do, because we can easily encounter situations just like this when we find zeros of polynomials. Okay, so let's take a look at that situation. We're going to take a look at this situation here in this example. What it just means is that we have to do just a little bit more extra work, okay? But not by leaps and bounds, I promise you. Okay. So what we're going to do here in step number 4 is we're just going to do synthetic division with -1 and 2 being our two guys that we want to go ahead and divide out. We'll put -1 here on the outside. We'll put all the coefficients of the polynomial here on the inside. 1, -1, 2, -4, and -8. Okay. All right, so what we're going to do here first is we're going to go ahead and bring the 1 down. Okay, we have 1 times -1, that's -1. We have -1 plus -1, that's -2. -2 plus -2 times -1 is +2. We have 2 plus 2, which is 4. 4 times -1 is -4. -4 plus -4 is -8. -8 times -1 is +8. And here, if we add these together, we indeed get 0 as our remainder. So this is exactly what we want to happen, okay? This is our predicted pattern here. Should happen here if we take out -1. Now again, I'm going to stress this here. Do not use the original numbers, the original coefficients. Okay, the only way we're going to be able to find these last 2 zeros, because we have maximum 4 zeros, we only found 2 out of the 4, so we have 2 more to go, is we're going to use this result here, this 1, -2, 4, and -8. We want to use that result and start paring it down even further using the second 0 that we have found here from our calculator. So we're going to use 2 out here with this next bit of numbers here. Okay. All right. So in this instance, I'm going to bring down the 1. We'll have 1 times 2, which is 2. Oh, your question was answered? Oh, okay. Well, good. 1 times 2, which is 2. We have -2 plus 2, which is 0. And that's entirely plausible. 0 times 2 is going to be 0. So that's fine. That can happen. Here we have 4 plus 0, which is 4. 4 times 2, which is 8. Okay. So here we have 0, which is our expected guy right here. 0 is with the 2 is what we found as a 0 from step number 3 there. So again, that was found here using our calculator. Remember, these were our possible zeros here. We found that if we plugged in 2 in our calculator into the function, we indeed got 0 back into the function. That's the purpose of using the calculator there. Remember, I'm not guessing 2 here, if that's what your concern is that I first found it as a possibility, and then I had to plug it in the calculator, found it was a 0, and now I'm proving it's a 0 here. Okay? Remember, in this step-by-step process, and the way I like to show things, typically, I'm not going to guess. I'm going to actually show it one piece at a time. Okay, so I don't like putting in guesses in a process unless it's absolutely necessary. All right, guessing is like the worst thing in math. So, because that's like if you take a multiple choice test and you keep answering letter C. It really doesn't work out all that well. I know because I did it once. Didn't work out so well. I mean, it was like that professor I had in grad school where I had a student tell me that a certain professor in their class actually gave a 50-question true and false test and basically set 49 questions to be true and one of them to be false. Like, oof, there you go. And that way you could easily catch who's guessing and who isn't. It isn't that hard. Why'd you put -4 and not +4 in the first part of the equation? Are you talking about this -4 here that we're referring to? This -4 and -8? If that's what you're referring to, Fritz? Because this -4 here, at least, let me see if I got this right. This -4, yeah, so this -4 here that you're referring to is the coefficient of x. Okay, each one of these numbers that you see here are the coefficients of the polynomial. So that's where this -4 came from, this top -4. This bottom -4 came from 4 times -1. So that's where this bottom -4 came from. Yeah, so again, I'm just taking the pieces apart here. So I'm just picking it apart one piece at a time. Okay? So again, if you go over the synthetic division part there, Fritz, then it'll make, again, just go over those rules there. It's going to make a whole lot more sense about what we're doing here each step. Now, let's talk about what the fallout is after taking out these two zeros here of this polynomial, because there certainly are some. Now remember, when we're doing synthetic division, we're cutting down the polynomial by 1 degree every time. So basically, the results of these guys is basically like x. We start with x to the 4th. This goes down to x to the 3rd. And this results in x squared. So this is the number of x squareds that we have. This is the number of x's that we have. This is the number that we have. We don't have a remainder here, so we're not going to really worry about it because we know it's definitely a 0. So the resulting polynomial, this is the important part here. The resulting polynomial is where we're going to go ahead and find our last two zeros. Okay? Ain't wrong, Jess. So these last two zeros here are going to be specifically x squared plus 4. So we factored out the plus and minus 4 and 8. hadn't known which to use, but you just take the sign. Yeah, that's right. So again, we use the calculator here to basically get that done there, Fritz. As long as we get 0 once we plug it in the calculator for our y value, then we know it's a 0. So again, that's what step 3 is there for, knowing what 2 we're going to use. In this case, 2 of them. That's what we found. Now, the resulting polynomial we have here is x squared plus 4. Now, this is important because we're going to find the zeros of this resulting polynomial. So again, let's put a little word of warning here. So you must find the zeros of this. Okay, so what exactly does that mean here in the grand scheme of things? Essentially, at the end of the day, we either need to use, we just need to use any one of the properties here. We could use quadratic formula. We could use, again, we could use just the square property here. It doesn't matter. So again, here, again, use a quadratic formula. That's pretty popular. Or a square root property. Either way, you're going to find last two zeros here. So let's showcase this out here. So we're going to have x squared plus 4 equals 0. Okay. We're going to go ahead and subtract 4 on both sides. All right. I have not, my friend. I have not. All right, so here we get x squared is equal to negative 4. Now we use the square root property. We can use the square root property on this. So we take the square root here. So x here is equal to, what is the square root of negative 4? What is the square root of negative 4? What's that going to be? Almost, Brian. Not quite. Okay, now what are we missing there? Okay, so here we get, again, we have the square root of -1, right, which is I agree. What's the square root of 4? In this case here, as I stated here earlier, plus or minus is in play. So we have plus or minus 2i, right? So again, plus or minus is in play here. So don't forget about that. It's always in play. All right. As told you before, either we're going to use the positive answer or we're going to use both plus or minus. And in this case here, plus or minus is in play. It's like what we talked about here in the question about conjugate pairs. You always get a BOGO, okay? You always get buy one, get one, all right? So you get plus 2i, you're going to get minus 2i as a result, okay? That's just how it's going to roll. So in this instance here, we get plus or minus 2i. So those are going to be our last two zeros in this case here. In this case, we get two more zeros here. We have -1, we have -1, we have 2, we have 2i, and we get -2i. Okay, so those are going to be our 4 zeros of our polynomial. All right, so that's the extra step that we may need to take here in order to find our last two zeros of the polynomial. Okay, and again, you're going to find two zeros here because they always come in pairs. All right, now again, like I said, you either use a quadratic formula, all right, or use the square root property. Okay. Yeah, there we go. Put form here. So our final result here, our final answer is going to be this. Here's our final answer. Our final answer is going to be, put it in factored form, putting this together. We're going to get x plus 1 times x minus 2, again. And we have plus or minus 2i here, so we get x minus 2i and x plus 2i. All right. And that's going to be our final answer for that. I'm going to add one more note here in just a second, but any questions about that so far? Just have one more small thing to add. So. Okay, so really quick here, I want to add one more thing here. I want to add one more thing here for your notes that is important. Okay, so especially this is true for like complex zeros. So let's say, for example, here, if let's say if we got, say, just as a quick example, we had 1 minus 3i and 1 plus 3i as our zeros, for example. Let's say if they're zeros, then the way we would write this out in factored form is we could write it like this. We could write it as x minus, and in parentheses 1 minus 3i. And then you could also write it as x minus 1 plus 3i, and you put that in parentheses. So you don't have to like distribute the negative necessarily. You can write it like this as a factored form if you had, say, both of those as zeros, if it's just like an expression like so. That also works for square roots as well. So if you had, say, 1 plus or minus the square root of 5, you would do the same thing that you see here. Just put that little expression in parentheses and just put x minus in front of it. And then this will be okay. So I just want to point this out here. We got plus or minus 2i here. But again, you can easily get answers that look like this. Okay, or again, you get 1 minus square root of 5 or 1 plus square root of 5. It'd be the same deal. So again, x minus 1 minus root 5. And x minus 1 plus root 5. Okay, so again, just kind of showing that off there so that way, again, you're not caught unawares about how to write those out in factored form once you get down to the final result. Okay? All right. All right, so that is, in effect, mostly the end of section 3.4. All right, cool. All right, questions about that? Any questions over any of those thingamadoos? Can I scroll to the top here of the notes? Yes, I can. Let's see. Top of today's notes was. There you go. Question 2 is rather long, so may want to take a screenshot of that. So. No questions? Okay. Very good. All right. Oh, and we actually took the whole time. All right, good. All right. All right. Thank you very much here, ladies and gentlemen, for coming on out to stream once again. All right. All of you have been very lovely here this wonderful Monday afternoon. All right. Thank you very, very much here. I hope all of you have a very wonderful afternoon / evening. Okay. Please take care of yourself. All right. Have fun, of course. And again, as always, I'm be on Discord here, or again, email me here to contact me here if you have any questions over homework and the like. And if you haven't done so already, please go ahead and give that chapter 1 and 2 test a try. All right, make sure you go ahead and give that a go. That's already been posted and ready to go. So please go ahead and, again, if you want to pace yourself appropriately, now's a good time as any to go ahead and start on that guy. All right, so you're not bogged down with a ton of work later. All right, so as you know, this semester goes by fast, so just want to be sure. Tomorrow here, yes, tomorrow we will be covering section 3.5 and possibly section 3.6. So that is what's on the agenda here for tomorrow. So we'll see how far we get with 3.5. There's a kind of a lot to digest in 3.5, so we'll see what we do. If we get through it rather quick, then we'll go over 3.6 as well. So we should be all right. All right. All right. Is the next test? So Brian, the next test there is on chapter 3. Then we have one separate test on chapter 4, and then we're gonna have chapter 5 and 6 and 6 and 7. So I'm gonna be probably this week. I'll be I'm probably going to be releasing those tests fairly soon. So probably this week, because I do have them partially made up already. So with them being partially made up, I will be releasing them so that way you'll have an earlier chance to work on them. Okay? So yeah, that's not a problem. I'm working ahead so that way you guys will have plenty of time of which to finish, along with the pace of the course. As we're getting close to the end of chapter 3. I'll be honest here. We got 2 more sections to go. So, oh no, 3 more sections I should say. Sorry. So, not yet, Blink. They will be soon though. Once I release the test, the practice test will go up at the same time. So that's how I like to do it. Practice tests at the same time as a test, so that way you have both of them at the ready. You don't have to guess. So, as I said here, the practice test looks exactly like the real test, so I wouldn't let you down like that, you know? I ain't gonna do you dirty, my dude. That's not how it rolls. I promise you, I ain't gonna do you dirty. I'll make sure that things are in the proper order so that way you have as plenty of opportunities to get the best grade possible, okay? All right. Any more questions before we head out? Hopefully everybody's doing okay. I do recommend that, yes. I do recommend that. I know everybody has their own pace of doing things, but I recommend that so that way you'll be able to move on, do chapter 3 stuff, and keep with the pace here. Thing is, what you don't want to do is you don't want to overwhelm yourself with work here close to the end of the semester. All right? That's just going to look. As I told you, the onus of responsibility is on you. So again, this is a good way to kind of make sure you get your work done early, you know? This is where you grow as an individual. We all like procrastination station. It's the best station to be around, but this is if you want to succeed, this is kind of like your way. I'm giving you as many outs as possible. Now it's on you. So I give you a recommendation, and if you want to take it, you can. If you don't, I'm not going to force you. So I just want you to do your best. All right? Anybody else? Any other questions? Please go ahead. All right. Thank you very much, Josie. Thank you very much, everybody. All right. All right. Again, contact me on Discord. Again, contact me on email if you want to. If you have questions, you need help, please feel free to contact me. I'll be right here waiting for you. All right. All right, everybody. Thank you so much for coming on out here to the stream. We're gonna come back here same time tomorrow. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have yourself a wonderful afternoon/evening. We'll see you tomorrow, everybody. Take care, everybody. Have a great one. All right. Bye.